In this video, I'm going to introduce graphics in Matlab, specifically how to plot curves and especially graphs of functions. As I'm going to explain, to produce graphs in Matlab, we have to know how to enter vectors, so that's where I'm going to start. Vectors are entered using square brackets. To enter a row vector, separate the components by commas or spaces. So here's a vector named x. Its components are 1, 2, 3, 4, 5. If I wanted to create a column vector instead of a row vector, I would separate the components by semicolons. And remember, if I don't want to see the output, I can end the command in a semicolon. Now here's a second vector. Of course, I didn't enter those components at random. The components of y are the squares of the components of x. Here's the basic plot command. It plots the points defined by the vectors x and y and connects them by short line segments. Now, what do I mean by the points defined by x and y? Well, x and y each have 5 components. If I were to take the first component of x and the first component of y, those two numbers define a point in the plane, the point with coordinates 1, 1. If I take the second components from both x and y, those numbers define a point in the plane, the point with coordinates 2, 4. Those are the points that I'm talking about. Since x and y both have 5 components, the two vectors together define 5 points. Notice that I've just shown you how to refer to the components of a vector. You use parentheses. If you were to use an invalid index, you'd get an error. So for instance, if I type x of 6, Matlab tells me that I've exceeded the matrix dimensions. Or I get a slightly different error if I try x of 0, since the index is not positive. You can ask Matlab how long the vector is, or you could also get this information using the whos command. There you see the vector x is 5 by 1. That tells me that it's a column vector. It has 5 rows and 1 column. It occupies a total of 40 bytes. Each component is a double precision number that requires 8 bytes. In order to demonstrate some other features of the plot command in Matlab, let me go ahead and define another vector. If I want, I can plot two curves in the same figure. Here I'll plot y against x and also z against x. Notice that by default, Matlab chooses different colors for the two curves. If I wanted to, I could instruct Matlab to use the same color for both. I'm choosing blue here. This is the result. Or I could choose two different colors according to my own preference for the two curves. Here I've chosen red for the first curve and black for the second curve. By default, as I told you before, Matlab connects the points with straight line segments. I could choose just to plot the points themselves, like this. And I can choose a variety of different symbols to mark the points. There's another example. You might imagine an example where you want to see both the curve and the points on the curve. So here I'm telling Matlab to connect the points with line segments, but then I'm also telling Matlab to plot the points again and indicate them with little circles. And then finally, notice that I can combine the color directive and the directive about the type of marker to use. So here I've told Matlab to plot the points in red and plot them as points. To learn more about how to use the plot command, you should use the Matlab help system. I want to remind you that there are two ways to do this. First of all, I can just type help plot in the command window. I get quite a bit of information. And in particular, if I wanted to know what are the colors that I can use, what are the symbols that I can use for the points, I find this in the middle of the help. Secondly, I could go up to the help menu, go to the function browser, type in plot, and I get a number of things to choose from. For instance, basic plots and graphs. And there I could choose the plot command that I've been using. I get the same information in this form. There's a lot of other information about other kinds of graphics that we will eventually go into, but you could explore them on your own if you want. Now let me clear the command window, and then let's talk about how to generate better graphs. What I have here is a graph of a parabola generated using only 5 points on the parabola. If I graph it in the more usual way, connecting the points with line segments, I get this, and you can see that the graph was generated by connecting points. In other words, what you really see is a polygonal line rather than a curve. If I want to generate a better graph, I would need more points on the curve. I could do that by simply defining more points in x. Obviously, though, this is kind of tedious. And then it would be even more tedious if I have to enter the values of y. Fortunately, Matlab provides a couple of mechanisms for doing this easily. First of all, there's a command called linspace, the purpose of which is to generate a vector with linearly spaced components. So, for instance, I could start at 1, end at 5, and use 5 points. This is the vector that I just had. I could instead start at 1, end at 5, and use 11 points. I should change the format so that we can see this more easily. And if I wanted a very accurate graph, I could use really any number of points, say from 1 to 5 with 101 points. Now I'm not going to look at the output because it's rather extensive. But I still have the problem of how to generate y. I don't want to have to type in the values of y one by one. Matlab has a mechanism called vectorization for accomplishing this. I can say y equals x squared. And what I've done is issue a command that tells Matlab to square the components of the vector one by one. Notice that I did not use the usual exponentiation symbol, but I used a dot and then the caret sign. In fact, let's just try it without the dot. If I just put x squared like that, I get an error because I can't square a vector. I cannot multiply a vector times itself in that way. However, when I use this other version of the exponentiation, I'm telling Matlab to square each component of the vector independently. Now if I plot y versus x, I get what looks like a very smooth curve. It's actually still a number of points graphed and connected by short line segments. However, the points are so close together that what I get looks like a smooth curve. Let's look at all the individual points. There they are. So you can see that the fact that I really obtain a polygonal line isn't very evident because the points are so close together. Let's change my graph a little bit. Let's go from -5 to 5 with 101 points. Y is x squared. And there I get a parabola as you would expect. What operations in Matlab are vectorized? Well, the answer is all the arithmetic and all of the built-in functions. So for instance, if I wanted to plot y equals sine of x from -5 to 5, I've already defined x. I can compute y equals sine x and plot it. And there I get part of the sine curve. So this function sine, which is a built-in Matlab function, is vectorized, meaning that if I input a vector, the function will compute the sine of each component of that vector and return the results in a vector of the same size. So for instance, if I look at my variables now, I see that y is a vector of the same size as x. I could plot the exponential function. Notice I don't have to actually define the new variable y. I can just plot exp of x versus x. If I do that, I'm not saving the value of exp of x, so I'm just using it in the plot command. So there's a graph of the exponential function from -5 to 5. How about some more complicated arithmetic? Suppose I wanted to plot the function 1 divided by 1 plus x squared. Now I've made a mistake here because I need to vectorize the division. I need to use the dot slash operator, not just the slash operator. In the same way that I'm using the dot caret operator instead of just the caret operator. There's the graph of y equals 1 over 1 plus x squared. Here's another example. Let's plot x times cosine of x. Once again, note how I use the dot times operator rather than just the times operator. Suppose I did it the wrong way. What I get is an error message. I can't multiply two vectors in that form. Now, if you think about the definition of vector addition, it's already vectorized. In other words, vectors are added component by component, so there's no such thing as a dot plus operator. I can just add the vector x to the vector cosine of x. Later in the course, when we learn how to program in Matlab, we'll see how to define vectorized functions for ourselves. Let's look at some more graphics commands. First, let's graph two polynomials. I'll define x to go from -2 to 2, 41 points. Y will be x squared, and z will be x cubed. I know how to graph x and y together. I do it like this. And there's my quadratic polynomial and my cubic polynomial together on one graph. Now suppose I want to plot them separately. So I'll plot y versus x. Now I create another figure window by using the figure command. And then I can plot x versus z. Now I have the two functions graphed in different windows. Now notice that the figures are numbered consecutively, so my first figure is figure 1, my second figure is figure 2. To create a graph in a given figure, I can refer to that figure by number. So for instance, if I want my next graphics command to go to figure 1, I choose figure 1, then I could plot, let's say, x versus x. Of course, that's going to be a straight line. Then if I want to send the next graph to figure 2, I can refer to that by name. And now I've graphed the straight line in that figure as well. I can close the current graphics window using the close command. If I want to close all of the graphics windows, I can use close all. Now let's recreate one of my graphs. I can annotate a graph in various ways. For instance, I can put a label on the x-axis, like so. I can put a label on the y-axis. I can put a title on the graph. The grid command is useful. It puts a grid on the graph. It makes it sometimes easier to read a graph or to get precise information from it. I can also make the grid finer by typing grid minor. Grid and grid minor are toggles. So in other words, if I type grid minor again, the minor grid is removed. If I type grid again, the major grid is removed. I won't spend a lot of time on these options that are found on the graphics window itself, but I will point out there's a zoom button. If I click that and then move my cursor to where I want to zoom in and click, left click to be specific, I can zoom in more and more closely. I can zoom out if I want. If I'm zooming in and I double click, I go back to the original view. Sometimes I might want to zoom in a more precise manner. The axis command is good for that. Using the axis command, I can specify the window that will be in view. So for instance, I might want to go from -1 to 1 in x, and also from -1 to 1 in y. Once I've created a graph, I might want to print it. I can use the print command. If I simply type print, it will send the current graphics figure to the current printer. Now I'm not going to do that because I don't have a printer attached to my laptop. But I can also print to a file. Using the -D option, I can choose the file type. I'm going to choose PNG, and then I can choose a file name. I just saved the current graphics window in a file called graphics.png. I can use other options. For instance, I can save the figure as an encapsulated PostScript file, or PDF, or PostScript, or there are several other possibilities. Of course, as always, I can type help print to get more information. And you'll see as part of the information, I have a list of options for file types. We'll learn more about graphics in Matlab later, but that's enough information to get started.